Good morning, students. Today we will complete the second part of the chapter, that is metals and nonmetals. Our first heading for the day is reaction of metals with water. Well, when metal react with water, it produces metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve to form metal hydroxide. All metals do not react with water as the metal plays lower in the reactivity series are less reactive towards water. Let's take few examples. Metals like potassium and sodium reacts violently with cold water. In case of sodium and potassium, the reaction is very violent and exothermic. Potassium, when reacts with cold water, gives potassium hydroxide KOH and hydrogen gas with heat. Similarly, when sodium reacts with water, it gives sodium hydroxide, hydrogen gas and heat. The heat evolved is sufficient for hydrogen to catch fire. That's why sodium and potassium catch fire when kept in water, and keeping this in mind, both these metals are kept in kerosene in order to avoid contact with both air and water. Next example is the reaction of calcium with water. It is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. When calcium reacts with water, gives calcium hydroxide and water and hydrogen gas. Calcium floats over water because the bubbles of hydrogen gas formed stick on the surface of the metal. Next example is of magnesium. Magnesium does not react with cold water. It reacts with hot water and forms magnesium hydroxide and hydrogen gas. It also floats over water due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminium, iron and zinc do not react either with cold or hot water. They react with steam and form the metal oxide and hydrogen. Aluminium, when react with H2O, gives aluminium oxide and hydrogen. Similarly, when iron react with water, steam water, it gives ferrous oxide and hydrogen. The next is reactivity order of metals towards water. As shown in the slide, potassium has higher reactivity towards water and gold has the least. Whereas non-metals do not react with water or steam to evolve hydrogen gas. Now, our next chemical properties of metal is reaction of metals with dilute acids. So, first we learn about the reaction of metal with dilute HCl and dilute H2SO4. Except a few less reactive metals such as copper, mercury, silver, gold, platinum, etc., all metals react with dilute sulfuric acid, that is H2SO4, and hydrochloric acid, that is HCl, to produce salt and hydrogen gas. When zinc reacts with dilute HCl, it gives zinc chloride and hydrogen gas. Means when metals react with dilute acids, it gives salt and hydrogen. Similarly, when magnesium reacts with sulfuric acid, it gives magnesium sulfate and hydrogen gas. Next is reaction of metal with dilute nitric acid, that is HNO3. Except magnesium and manganese, metals do not evolve hydrogen gas with dilute nitric acid. This is due to the oxidizing nature of nitric acid. As soon as hydrogen gas is formed in the reaction between a metal and dilute nitric acid, the nitric acid oxidizes this hydrogen to water and itself gets reduced to NO2 or NO or N2. In normal cases, metal when react with nitric acid, it gives dilute nitric acid, it gives salt NO2, N2 or N2O with water. But in case of manganese or magnesium, which is an exceptional case, these two metals react with nitric acid, gives salt and hydrogen gas. As you can see the reaction, when magnesium reacts with nitric acid, dilute nitric acid, it gives magnesium nitrate, MgNO3 whole twice, with hydrogen gas. Similarly, when manganese reacts with nitric acid, gives magnesium nitrate and hydrogen gas. Nonmetals do not react with dilute acids to release hydrogen gas. Now, the next topic is aqua regia. It is a freshly prepared mixture of concentrated HCl and concentrated nitric acid in the ratio of 3:1. It can dissolve gold, even though neither of these acids can do so alone. Aqua regia is highly corrosive. Fuming liquid, it is one of the few reagents that is able to dissolve gold and platinum. So, the last chemical property of metals is reaction of metals with solution of other metal salt. A reactive metal can displace a comparatively less reactive metal from its compound in aqueous salt solution or in molten state. General equation is A, which is a reactive metals, when react with BC gives AC plus B. So here A is more reactive than B, so it will displace the position of B and form AC or salt of metal A. For example, when copper reacts with silver nitrate, it gives copper nitrate and silver. This type of reaction is called displacement reaction. So the last topic of the day is reactivity series. On the basis of their relative tendency to lose electron and their reactive nature, metals are arranged in a series. This series is called activity series or reactivity series of metals. The metals that are placed above hydrogen are called active metals, that example potassium, sodium, calcium, etc. And the metals that are placed below hydrogen are called inactive metals or less reactive metals. For example, noble metals, that is gold and platinum. So, question arises, what is the importance of reactivity series? There are two importance. In reactivity series, metals that are placed above hydrogen can displace it from hydrogen from dilute acid, that is HCl and H2SO4. Second is metal placed above another metal in the series can displace it from the solution of its salt, as the metal placed towards top is more reactive than a metal below it. Students, this completes our second session on chapter metals and nonmetals. Go through these slides and revise them regularly. Thank you and have a nice day.